Hey Algo devs, my name is Sara. Today I have a really exciting thing to show you, how to do X402 on Algorand. So let's get straight into it. So once you come into the Algorand developer portal and you click read the docs, you'll see on the left hand menu at the very bottom there's additional resources. Once you expand this menu, you'll see X402 on Algorand. Great, so let's have a little look about X402 on Algorand. X402 is an open payment protocol that lets services charge for API access directly over HTTP. Clients pay per request using the 402 payment required status code. No sessions, API keys, or credential management required. Now, the protocol has three participants. Number one, a client sends a request. Number two, a resource server returns payment requirements or the response if already paid. And finally, three, a facilitator verifies, settles payments on-chain. You can take a look at this comprehensive diagram of these three systems working together. And of course, the facilitator is submitting and getting the transaction details confirmed or settled on Algorand. But we're going to jump straight into the tutorial. And for the tutorial, you will not need to build a custom facilitator. We'll be using a hosted one. So we're walking through the protocol by building a working example on Algorand Testnet. You will build a pay per API weather endpoint. Unpaid requests get 402 payment required, and paid requests get a JSON back. You will, number one, build a client that automatically pays when it receives a 402 response. Number two, build a resource server that charges for get weather endpoint. And number three, run both locally end to end. So here are some of the prerequisites you'll need: Node.js and PNPM. And there's also a setup, which is quite important. And I feel like it's better to get the setup over and done with, so then when you're just going through the code in the tutorial, you can focus on that rather than trying to get all the different pieces working and wired together. But it's quite simple. What you're going to do is create two testnets account, one for the client, the payer, and one for the resource server, which is the receiver. Of course, you can create just one wallet, and between both of them, just share the one wallet. But if you wanted more of a realistic approach, you could split it and have two different testnet accounts. So you're going to fund both the Algorand accounts with testnet algo using the LoRa faucet. And once you do that, you're going to opt both accounts into testnet USDC through LoRa or any of your Para, for example. Then you're going to get USDC on both accounts from the Circle testnet faucet. You go to the link that is hyperlinked here, select Algorand Testnet and fund each address. Then you're going to save these values for later. The client's payer mnemonic, which we're going to use as AVM mnemonic within the env file, and the resource server's public address used as AVM_address. We also have a caution here. Never commit mnemonics or private keys. The .env files in this tutorial are for local development only. In production, use wallet integration, KMS, or another secure signing path. Let's get to the first step. In this part, you'll build a client that sends a request, handles the 402 response, signs and submits payment, then retries with proof of payment. You'll test it against a hosted resource server before building our own in part 2. So we're going to create the project first. So we're going to create the directory, jump into it, and PNPM init. As you can see here, I have a blank X402 directory, but I'm just going to paste in the setup instructions. Perfect. Next, we're going to add TypeScript tooling. As you can see as well, let me move myself up. We have a ignore build scripts for the ES build. So what we're going to have to do is run pnpm approve builds. We're going to click space so we can select ES build and press enter. And do we approve? Yes. So we click Y. Perfect. This means we won't have any blockages later. Next, we need to install the dependencies like X402 core, X402 fetch, X402 AVM, Algorand Foundation algo key utils, and .env. Note, this tutorial currently uses an alpha release of Algorand Foundation AlgoKit utils. We will update the guide to the corresponding beta release when it is available. So we'll just let this install the dependencies, it's quite fast, and we head back to the instructions. We still have a little bit of setup to do. We're going to create the tsconfig.json in the project root. So let's do that. tsconfig.json, and we'll paste the setup right here. Next is our environment variables, and you should always add your .env to the .getignore. I won't be uploading this to GitHub, so I'm just going to keep it local, but we're going to enter our AVM mnemonic, so I'll be right back while I do that. Great. As you can see here, I created my .env, and I also created .env.template so you can see what it should look like. You have your AVM mnemonic, and then followed by your keywords. Now, let's get on to our first plain fetch so we can expect 402. So before adding the X402 libraries, we want to confirm the endpoint requires a payment. A plain fetch should return HTTP 402, and we're calling the global resource server for that. And then we're obviously going to console.log it out, the status, as well as the payment header. So let's create our index.ts file, paste in. So now let's run this. And what you'll see here is we get our status 402 required, and we can see the payment required. Perfect. Also, remember, if pm prompts about build scripts, run pm approve builds to allow native builds required for ES build. So as you can see, we got the expected output. Now we're going to add the X402 payment support and replace what we currently have for the paying version. So instead of plain fetch, we're going to wrap fetch with payment, which intercepts the 402 responses, signs an Algorand payment using the mnemonic form AVM mnemonic, and retries the request with the payment proof attached. This requires the setup above, if you remember, getting your funded account, asset opt-in, and testnet USDC. Here you can see we are importing certain things from the X402 libraries. We're setting up that we're still calling the resource server that's already been hosted, as well as our main function. So we're creating the Algorand signer used to authorize payments. We're also initializing the X402 client, registering Algorand Testnet as scheme, and we can also see what our signer is by console logging that. We're going to wrap fetch, so 402 responses trigger payment handling automatically. Make the request. If the response is okay, we're going to read the payment settlement headers. We're going to also console log those out so we can see them, as well as read the resource server response body. At the bottom here, we're building the base64 encoded signing key that X402 AVM expects, and also up to more of the latest tooling that the AlgoKit utils has. So if you go back in here, remove what's currently in the index.ts. Perfect. If we run this again, we should get, perfect, the AVM is signing. We can have a look at the payment response, so it's a success. We can have a look at the transaction as well. It's on the Algorand network, and there is the payer. We can also see we've got the weather response. So we can see that from using the global resource server, we were able to get some different weathers all across the world, which is what we were expecting. I did want to show you guys what it looks like in LoRa, the transaction. So if we come down here, and I'll zoom in, we could see it was quite a simple 0.01 USDC. That's the charge to get the weather responses. And we also have in our notes the X402 payment. So heading back to our tutorial, we can see we got the expected output. And now we're into part 2, build a resource server. In this part, you'll build a resource server that hosts a weather endpoint. It returns a 402 response when a request lacks valid payment, and delegates verification to the facilitator, only serving data once payment is confirmed. So we're going to do the exact same thing and create the server project. So inside of the terminal, I'm going to create the new project. You can see it came up on our left-hand side. We also need to add the TypeScript tooling, just like before, as well as the dependencies. So here we're going to use X402 core, X402 AVM, Hono server, and .env. Great. We also still have that ignore. So let's fix that really quick by doing pm approve builds, select ES build, and perfect. Next, what we're going to do is the server config. Very similar. We're just going to copy from the ts config.json from the client config. And just so it's even quicker, what you can do is go to your old one, or not the old one, the one from the client, copy it, and then paste it inside your new for the server. Perfect. Next, we need to set up our environment variables. So you're going to add .env to .getignore. Of course, if you're pushing this anywhere public, make sure you do not leak any sensitive information. And then also create the .env. So we're going to use the AVM address and the facilitator URL. We use the resource server's account public address for the AVM address, and the facilitator URL points to the hosted facilitator by global, so you do not need to run facilitator code for this tutorial. I'm going to set up my .env and I'll be right back. Perfect. As you can see, I have now the .env with the address and the facilitator URL. Now let's implement the getWeather endpoint. We're going to create index.ts at the project root, and the payment middleware function intercepts incoming requests and checks for a valid payment proof before forwarding to your route handler. Unpaid requests get a 402 response with payment instructions, and the accepts array defines what the server will accept as a payment. Each entry specifies the scheme, price, network, and recipient. The network value is set at Algorand Testnet. It's basically just the CAPE2 identifier. We don't need to go that deep. And this tells the client which chain to submit payment on. As we can see here, we're importing what we need from the X402 libraries, as well as Hono and .env. We're initializing the resource server. We're registering the network scheme. And we're using a protected route middleware. As you can see, this was the accepts that we've seen earlier. So we defined different things here. For example, our price is 0.005. After this, you get your resource handler. So you can return, and this is what we've sort of hard-coded, the weather, the temperature, and the timestamp. So let's put this into our index.ts file. So I just pasted in the index.ts right there. Now let's go back to the instructions, and we're going to go into the final section, which is running locally. So in part 1, we hit a hosted resource server. Now we've built one, so we're going to point the client at our own local server so you can see the full flow end to end. But first, we're going to start our resource server. And we'll know it's running because it will say resource server is listening at localhost. Next, we're going to point the client at the server. So we're going to jump back into the client index.ts and change the URL to your local server. So if we go into our demo client, go to the index, we can see here we're currently pointing to global, but we're going to point to ours. And as you can see, this is our local host, and then this is our endpoint, which is the weather, which is what we're going to call from our resource server. Next, we're going to run the client. What we should get is the weather JSON after the payment settles, and the output should look similar to part 1, with of course the local server's transaction details. So let's run this. We have the resource server running in one window, and in another we're going to run the client. So we can see here we have our AVM signer. We also have our payment response, which is true. We get our transaction, and we also get our weather response, which is the weather sunny, temperature 70, and the timestamp. So congratulations, you've just ran your first end-to-end X402 payment on Algorand, building the client side and also the resource server. Now, if you want to run your own facilitator, you can check out the link at the bottom here, where you can go to a bunch of repos that have lots of different examples. It will also be getting updated, hopefully before this video comes out. We also have some extra handy next steps, the X402 demo examples, X402 on Algorand, developer resources, and x402.org. If you have any questions, you can come join the Algorand Discord, or feel free to add us at AlgoDevs on X. Thank you so much, AlgoDevs, and I hope you have a great day.